So the last two sections that we're going to talk about are basically what we've been doing. So eigenvalues and eigenvectors to solve systems. However, the systems we're going to take a look at today and tomorrow are going to have they're going to be non-homogeneous systems, meaning that we're going to have to also find a particular solution. So in a nutshell, we do what we've been doing to find the homogeneous solution of the system. And then, depending on which method you want to use, today we'll do undetermined coefficients. Tomorrow we'll talk about variation of parameters. Depending on which method, then that's going to be what you use just to find the particular. Okay, so today we'll start with kind of the easier one to digest. This is going to be a pretty decent method, but it only works when we have those nice functions that we like. So it only works for constants, polynomials, exponentials, and sines and cosines, the usual. Okay, so if you see a system such as this one, say we have x prime times 1, negative 3, 2, negative 4 times x. So this is what we did the previous section, homogeneous system, but now we're going to have a little bit more to that. We're going to have an f of t matrix. So let's say we have 5, negative 8. Okay. So the first part is basically ignore the fact that we have that f of t and solve the homogeneous version of the system first. So that means find the what? And that'll help us find the eigenvalues. So that's 1 minus lambda, negative 3 to negative 4 minus lambda. Multiplying that out, we get negative 4 plus 3 lambda plus lambda squared plus 6, which is the same as lambda squared plus 3 lambda plus 2, which factors? Yep. So lambda 1 will be, let's say, negative 2, and lambda 2 will be negative 1. Okay, so nothing's changed yet. Let's go ahead and find the first eigenvector. So now we have a plus 2 times the identity, augmented with 0. So take the coefficient matrix and add 2 along the diagonal. We get 3, negative 3, 2, negative 2. I mean, you guys have been doing this enough now. I mean, you just know what it's going to be at this point, right? So this tells us the relationship that K1 and K2 have to be the same entry for this eigenvector. You can do whatever choice you want. I'll use 1, 1. Okay, and why don't you guys take a few seconds and find the other eigenvector? What did you guys get? K1 equals 3/2 K2 is a good relationship. So K2 is 2. Sure, that works. Okay, so at this point, we have found what we call the complementary solution, just like with non-system equations. And that solution will be C1 times 1 e to the negative 2t plus C2 3 e to the negative t. Okay, and now we have to change gears for a moment. And basically, the method of undetermined coefficients for systems, you look back at the original system, you say, well, gee, this looks like a constant matrix, so a good choice for a particular solution would be a constant matrix. So let's call it A1, B1. And again, this is since f of t was constant. Okay, now to figure out what these need to be, you're going to take the particular solution, which is currently A1, B1. You're going to plug it back into the original system. Okay, so we're going to have to find the derivative of A1, B1, multiply it with 1, negative 3, 2, negative 4, and then add 5 and negative 8 to it, and just take a look at what happens. So if we plug this in, on the left side we get 0, 0, because the derivative of two constants will be 0 with respect to t. On the right side, we're multiplying A1, B1 with, I could just write it down. So that's 1, negative 3, 2, negative 4 times our particular plus 5, negative 8. So what's this product going to be here? There we go. And then the bottom row would be good. So this 2 by 2 by this 2 by 1. I know this looks kind of strange, and believe me, they're going to look even stranger, but this is just a 2 by 1 matrix, right? So don't forget that this is not a 2 by 2. It's kind of easy to make that mistake. Okay. So now from here, we have a system, yeah. So first system is that A1 minus 3B1 has to equal, if I move the 5 over, negative 5. And then 2A minus 4B1 would have to equal 8. Solve the system, why don't you? What do we get? B1 equals 9. A1 equals 22. And B1 equals 9. Okay? So then this means that our particular solution is just this little constant matrix 22, 9. Say that again? Yes, so the final answer, very good. As we learned with the non-system version of non-homogeneous equations, you take complementary solution, which was right up, oh, I moved it up, right up here in pink, C1, 1, 1, e to the negative 2t, plus C2, 3, 2, e to the negative t, and then the particular is just going to be 22, 9. Nope. Yet.
Why is it all set to zero matrix again?
Because we actually, it's a good question, we plugged this in. I know it doesn't seem like it, but remember the original system was this one, right?
Yeah.
So if a particular solution is some constant matrix, when you take the derivative of that matrix on the left side, the derivative would be 0 for both entries. Does that make sense?
Yeah.
So that's all we're doing, is plugging it into the x prime and also into the x. And that's what gave us this. Anything else?
So if there's a T in there, you do it the same way.
Yeah, so we'll do one more example, a little bit more complicated. And then the idea basically is looking at the f of t and being able to identify, well, this is what the particular solution must look like. And if you can do that, then you should be in good shape. All right, so let's say we have dx dt equals 6x plus y plus 6t. And let's say it's dy dt equals 4x plus 3y minus 10t plus 4. Okay. So I don't know about you, but I do like writing it in that condensed form. It's just easier to look at. So that would be the same as x prime equal to 6, 1, 4, 3. It looks like we're going to have two separate matrices here. We're going to have one that will be times t.
You can't just combine it into one.
You could, but it'll make sense because when we do the particular, you're going to have one for each. If we have a t term, we're going to have a matrix for that. And if we have a constant, we're going to have a matrix for that. So the coefficients for t would be 6, negative 10. And then our constant matrix would just be 0.
Do you want to put like an X after the 6 or
Oh, yeah. Thank you. Okay. So again, ignore this to start and just solve this system. So find the eigenvalues and find the eigenvectors. I'll start working through that. You guys can probably beat me there. My two eigenvalues are 7 and 2. Is that what you guys are getting? Okay. If you plug in 7, subtract 7 along the diagonals. I'm getting the same eigenvector that we had in the first one for K1. 1, 1. For lambda 2, subtract 2 along the diagonals. Where am I? 4, 1, 4, 1. So that's the same as 1, 1/4, 0. So K1 equals 1/4 K2, negative 1/4 K2. So, I don't know, 4 for K2, negative 1 for K1. Okay. So our complementary solution, C1, 1, 1, e to the 7t plus C2, negative 1, 4 times e to the 2t. All right, and now the particular solution would have to look like what? I'll use A1, B1, but yeah, T. And then we did have a constant matrix, so A2, B2. Okay, and it's pretty much the same process every time. I just wanted to do one that was a little trickier with you guys. So yeah, take this, plug it in to the original system. So on the left side, if I take x prime for the particular, that would be, yes. And now I'm just going to write this out. 6, 1, 4, 3 times the particular, A1, B1, T plus A2, B2. And we still have 6, negative 10t, and 0, 4. Okay, so this is what we're looking at. So if I take the first product, that's times t, right? So I'm going to have 6a1 plus b1. I'm going to group all the t's together. So 6a1, b1, that's all times t, and I have this extra t back over here, right? So I'm going to go ahead and squeeze that in now. You guys see how I'm getting that? Okay. And I'll go ahead and do the same with the bottom row. That's 4a1 plus 3b1. And then if I follow bottom row along, I have a minus 10t as well. And now I'm going to go ahead and do the same thing. Multiply this matrix to this next 2 by 1, which is just the constant matrix. So that'll be 6a2, or yeah, 6a2 plus 1b2, and that's just plus 0. And then 4a2 plus 3b2, plus 4. So I have my t term and then my constant term at the end here. Okay, and I'm going to, probably the easiest thing to do would actually be to go ahead and kind of set this equal to 0. So if we take this left matrix, I mean, it doesn't really matter, but
Oh.
the idea behind this is that if we're going to solve this system, which, by the way, is 4 unknowns, right? 4 equations, technically. Now it's easy to see the 4 equations because, oh, I forget. You can't see me pointing up there, down here. Okay. If this equals 0, then this coefficient must be 0, and then this whole constant must be 0. Does that make sense? And it's the same argument with the second row. Okay, so from here, the first system we'll take a look at is 6a1 plus b1 plus 6 equals 0. 4a1 plus 3b1 minus 10 equals 0, which if we put in the usual format, looks something like this. And if we solve for a1 and b1, why don't you guys do that? What are you getting? a1 is negative 2, and b1 would then be 6. Okay, halfway home. Now, the second system, which now that we have this isn't so bad, because here we have 3 variables technically in each one, but we now have a1 and b1, right? So that's going to be 6a2 plus b2, and since we know a1, I'm just going to go ahead and put that on the other side. Minus negative 2 is positive, so then that's technically negative 2 on the right. And then 4a2 plus 3b2, let's see, 4 minus b1 would be negative 2, so that's 2 on the right. So even though this had 3 variables to start, once you have the first system solved for, you typically what's going to happen is this: you're going to take the first system and then kind of plug those values into the next one, plug those values into the next one if there's more. Okay, and in this case, what do we get? A2 is 7. 2 sevens. 4 sevens. Minus 4 sevens.
Baby, we got minus 2 sevens.
Uh-oh. All right.
I got A2 and B2.
Let's do it together.
Fractions.
So 3, I'm going to multiply by 3 and subtract. 18 minus 4 is 14. Am I good? Yeah.
Oh, that's right.
3 times negative 2 is negative 6. Minus 2 is negative 8. That looks like negative 4 sevenths.
Yeah.
Okay, so if we have negative 4 sevenths, then B2 is going to be 10 sevenths. Okay. Okay, now we're done. So the final solution is C1, it's this purple one up here, plus the particular, which is going to be this with the values plugged in. So C1, 1 e to the 7t plus C2, negative 1 4 e to the 2t plus negative 2 6, and then that was times t, plus negative 4 sevenths, 10 sevenths. Make sense? Okay. Like I said, the concept isn't so hard. It's just they take a long time. It's the same idea. Yeah. So if we have cosines and sines, then you would just use that as your particular. Okay. One more, and we're not going to solve it.
What are the comments on your videos like?
What's that?
What are the comments on your videos like?
Some of them.
Is it as many sad things?
No, they're all very excited.
Trying to
We can take a look. Okay. Find the general form of the particular solution. This won't take us very long. So let's say we have x prime equals 2, 5, negative 1, 4 times x minus 2, 1 e to the 5t plus 0, 1t plus 6, 9. How many matrices would the particular have? And first one would be a1, b1 times e to the 5t, yep. And then a2, b2 times t, and constant matrix. I mean, like I said, not a hard concept. No, I mean, this will take care of itself because this is just going to be part of the system that we use when we plug in this particular solution. If we're starting by just assigning constants to these, we don't want to put negatives in there yet. That'll take care of itself as we work through the solution. Okay. Any questions? All right. And that is it for today.